Hi everyone, so in this video we will be discussing your lab 3, which is titled temperature during phase changes. So in chapter 3 we are working with matter and energy. So phase changes has to do with matter, right? The physical changes between solid, liquid, gas, those are called phase changes. So solids melting, for example, into a liquid, that's a phase change. Or the opposite, a liquid freezing into a solid is a phase change. So temperature is important because for many of these phase changes, energy is required. And temperature, all it really is a measure of kinetic energy. So if kinetic energy changes, then that means temperature changes, which causes a phase change. So that's how these are all kind of interrelated, how your lecture material is related to this lab. I just wanted to provide that context so that you understand why I assigned this lab. I always try to connect it, your current lab, to your current lecture material that you're working on. So hopefully that helps provide that context. So we are starting off with part 1. As always, Pivot really likes to have the lab assignments set out in parts. So part 1, you are looking at the temperature changes during melting or freezing. So specifically, you are looking at a solid and a liquid, right? Going from a liquid to a solid or a solid to a liquid, which is melting and freezing. So if you need a refresher on how to use the Pivot Interactive's video player, please open that up and just watch that before you get started with this lab. Especially remember that you have a tool here, which is a stopwatch. That's going to be really important for the rest of this lab. So just click this little tools icon and it shows you the little stopwatch, and then if you click it, it shows up right here. Or you can drag it around wherever you want. So you have your video where some measurements are taken, and first part is kind of like a prepper, like it just kind of helps you get established on what's going on. So you are going to watch the video and answer a few questions related to this. You're just making some observations. So for example, is the substance in the test tube a solid or a liquid? So you are going to make those observations. You are also going to make some measurement observations. So you are going to determine the temperature of the substance in the test tube when it's first placed in the water, and so on. So I won't go on too long about that because I think this part is pretty straightforward. And then here on question 6, it kind of lets you know that in part 2, we're going to be making measurements. So in part 2, you are taking the measurements and then graphing as you have done previously. And in the part 2, you are actually looking at the video in 15x normal speed. So this one doesn't want to play for me. Wow, it's messing up. But the next one, I'm sure you've had to deal with that. But in the next part, we are looking at 15x. So here I have part 2 opened. So once you finish part 1, once you're done with part 1, you should know whether your answers are correct, right? You can tell whether you selected the correct answer or not based off your submissions. So just click lock. If you're not ready to move on, do not click lock answers and continue. Just stay there, and when you're ready, then click lock. And then you can move on to part 2. Wow, it doesn't want to play again. Anyway. So in this Video, you have a similar situation. You should open up your stopwatch once again and load. Maybe that will, okay, there it goes. So notice that these have different load. These have different times. So it may or may not say here that it is 15 or 60, for example. I was pausing because I wanted to make sure I was going to say the right thing. So on trial 1, it's 15x. On this trial, which is trial 3, it's 60x normal speed. So you can see that the time's going by really fast here, and that's okay. You just have to pause it at whatever time you happen to be taking your measurement at, and you record. Okay, 38.6. The temperature was XYZ, right? So for this portion, I am looking for, at minimum, 25 measurements for whatever trial you happen to choose, right? So depending on the trial, you will have different measurements of time, right? Different increments. So that depends on which trial you choose. So, for example, here, this video is going by very fast. It's at 60 times the normal speed. So your increments may be, I was going to say slightly, but your increments are going to be a lot larger. But at minimum, for any of these trials, I am looking for, is a better way to say this, I am looking for at least 25 data points. 25 different increments that you recorded for time and the corresponding temperature. So one of these columns should be time, one of these columns should be temperature. Make sure to include your units and what variable. And also in this column name, please make sure to include the trial. So let me do better. Time for trial 3, for example, right? And then temperature for trial 3. And then units would be our degrees Celsius, which I don't have the symbol, so I'll just put degree. And then our variable is time, once again, or you can abbreviate it for, I actually wouldn't abbreviate it here because they're both T. Our temperature, oh gosh, look at that. Did y'all see that? That big mistake I just made. That's okay, because you're still working on it. It happens to me. My brain just doesn't work sometimes. So time is actually, what is it in? Yeah, minutes. Minutes. So we're working with minutes. You can type it out. And then here, this is temp. Okay? So it's okay to make mistakes. Just fix it before you submit. Okay. And then, like I said, at minimum, so let's say you have 10 here, your temperature's 20. You can keep entering, by the way, as long as you just click enter. So I was on the last, quote unquote, the last row, what it looked like, but all you need to do is, if you entered your, your data points on this final one, click enter and it'll open up a new row for you. Okay, so keep that in mind. That's how you add more rows. Just if you're on the last one, just click enter. Let's say and these are just numbers I'm just making up. Don't take these seriously, but just to show you, what I'm gonna do right now is just click enter or return on your keyboard, and then it opens up a new row for you. Okay, so that's how you add more rows. So that's what I'm looking for there. And then here for the graph, you are going to show me the portion I am looking for, or the lab calls for time. Oops. You don't have to have that. And then temperature. So we are going to look at how temperature changes as time goes on. That's the graph this is the data that you want to see graphically, visually, right? And here, this suggests for you to select the trial number dependent on your birth month. So go ahead and do that. Just make sure to please, this is my fourth please let me know which trial you selected, because that is very relevant to how your graph is going to look, right? Depending on who chose what, or what trial you chose, it's going to look different. So please, you can put it here as well. That helps a ton. You can add it here to the name of the time and temperature. In addition to here, you can add it there, and that will help me in the grading process. And then of course, please state it here. So I gave you kind of some information on how many data points to record, right? I said record at minimum 25. I think that will give everybody a really good visual representation of this data, and I think it'll help you understand the phase change and what's happening with the energy a little bit more. And then I kind of told you here too what should get plotted on each axis, but I want you to say this in your own words as well, in addition to explaining how to set up the data table. So you have all the information here, right? I gave you like a just verbal quick version of this, so I want you to kind of synthesize all of that and add it here. Now after that, what do you notice about the graph? So once you did all of that, what do you think is happening to the substance? So I'm going to tell you verbally what I will be grading here, okay? So you know what I am looking for. So I will be looking for one, your completed data table. So I'm typing this like if it's an answer, but it's not, okay? So I'm just typing this so that you can make a list. So I'm looking for the completed data table. I am also, let's make this, yeah, there we go. I'm also looking for you recognizing what's going on during heating. So what is happening during the heating portion? I also want you to recognize what is happening during, there's going to be a very obvious section after the heating. So what's happening after the heating, basically. And then finally, what's happening at the end after melting. Okay? So I'll leave it at that. I want you to describe to me what is happening on the graph at these different portions, at these different stages, right? So these are the 4 things I'm looking for. Each thing I'm looking for is worth 5 points, and that makes up the 20 points here. So hopefully this gives you some clarity on part 2. Please let me know if you have any questions at all. But I pretty much outlined what I'm looking for, and hopefully that clears up any confusion. So next, here's a table showing the melting points. So kind of in the same idea, right? Just to give you like an example to compare to. Remember, you use the density that you determined from a graph in lab 2 to determine what metal the pennies were made out of. So whatever density matched, whatever density on the little table that I had here with a bunch of different metals, whichever one matched the density you got on your slope, that was what the pennies were made out of. So here you're going to do something similar a little bit. So you are going to look at your data once again, and you're going to determine what your melting point was. And that way you will be able to compare to this table with all the different substances, and you will be able to tell what melting point matches which substance, and that's your substance for your trial. So you'll see that in your graph, there is something occurring after a certain point of time, which is melting. And that range is your melting point, okay? I don't want to give away too much because I do want you to write some information here. So I'll leave it at that. But just know that this range here is relevant to how your graph looks. And keep that in mind, that you can always reference your graph to help you answer this question. So all I'm looking for here is for you to give me the correct name of the substance. So you can write it in a sentence. That would be best, just because I like y'all to practice your scientific writing. So you can say the substance, let's say, I'm just making something up. Don't take this for like at face value, because I'm just making an example of this. So the substance in, I'm going to say trial 27, because we don't have a trial 27. This is just an example, was palmitic acid. Oh my god, I can't spell anything. Wow. Anyway, so that's all I'm looking for you to identify the substance by saying what it is. Okay. Moving on, in part 3, here is a video of the substance in trial 1. I think that should say the. So it starts off as a liquid, forms into a solid. So there's something unusual about this. So once again, you will be analyzing data and recording data, and here I'm actually looking for more data points. So this one's going to be a little bit long, but it's okay. You have about a whole week. So I think you have enough time. So for this one, I would like to see at minimum 35 data points. So you should keep entering until you see 35 right here. So I'm going to let you make the decision on how much the increments will be, like how much you increase each increment by. Remember, you're measuring time and temperature, right? Your time comes first here, and then your temperature is over here. So I'm just reminding you on how this is going to look. But I would like to see at minimum 35 data points. Again, not because I'm trying to make y'all suffer, not because I just am making you do busy work for the sake of it. No. It's because the more data points you collect here, the clearer this data is graphically, and it helps you come to some conclusions about what is going on. Okay? Once again, you're going to make a graph in a very similar fashion as the previous one. So pretty much follow the previous instructions I talked about. And then you are going to, again, like I mentioned, make some conclusions about this. So what do you notice about how the temperature changes as the substance makes the transition? So if there's anything odd, just list it here. You can do a few sentences and that would suffice. Or you can do more if you just want to kind of talk about everything you noticed. I would love that. The more observations I see from you. So please let me know if you have any questions at all. If you need to, rewind this video. I mentioned what I'm looking for and how I am grading. So please take that into account. And I will, that way we are both clear on each other's end, what you submit for you, and on my end, how I'm grading. So please let me know if you have any questions at all. And before I go, actually, so I told you how I am splitting up the points grading for this question on part 2, right? 5 points for each of these observations for you know, typing out in full sentences observations for each of these and how you did this. For this question on part 3, there's 10 points. The table and the graph are worth 10 points. So I'm going to say this verbally. 3 points will be scored for your time data. In other words, your time column. 3 points will be for your temperature data. 2 points for titling your columns. In other words, all this right here. And then 2 points for the graph axes, meaning you have to put these correctly. So time, temperature, there you go. So it's all about collecting the data and then making a conclusion about it after this. And this is graded depending on your observations, and hopefully they're kind of along a good path. I don't want to say correct or incorrect because everybody's different and kind of makes conclusions a little bit differently. And that's how I grade. I look at I look at things holistically, meaning I look at the assignment as a whole. Okay? So hopefully that helps. I think I went on longer than I should have, but hopefully this helps, and please email me if you have any questions. Thank you for watching.